Well, how are you doing? This video is going to be titled Global Polaris Problems. I'm making it due to many years of our opposition not being able to understand um, why Polaris appears to drop in the sky by 1 degree for every 69 miles you move away from it, or rise in the sky by 1 degree for every 69 miles you move towards it. So their only answer is that the Earth is curved, but this is completely wrong. Anyway, I get on with the video. I have a lot written out, and I have some diagrams and stuff to show at the end. So, global Polaris problems. Okay, these are misunderstandings from our opposition, which there seems to be an ample amount of in every topic. Okay, our opposition have a terribly difficult time understanding how and why Polaris appears to drop in the view of an observer by 1 degree for every 69 statuate miles that an observer travels away from it. Polaris is the only stationary star in the sky, as every other star is in motion. Polaris is actually the baseline for all celestial navigation. To explain this better, how Polaris became the baseline for all celestial navigation was because sailors found out that by making what we today know as 69 statuate miles of a distance from the star would appear to drop by 1 degree in the sky above. This allowed them to experiment with the sky as once they treated the Earth and sky as two parallel flat planes, they then found out that the other stars would also drop by 69 statuate miles per degree. They found that any star that was at their zenith would have a GP ground position of 69 statuate miles away from them once it moved from 90 degrees to 89 degrees, etc. This gave them confidence that by using degrees of angle that they could determine which part of the Earth a star resided over. Known as a GP today, this star location on our star zenith could be used as a radius line for a circle of which every part of was at an equal distance from the zenith position of the star, a circle of equal altitude. There is a misconception on our opposing side that the reason for Polaris dropping by 1 degree every 69 statuate miles of distance is due to the Earth being a globe, but this could not be further from the truth. And the reasons being that there is no perspective taken into account, for one. Secondly, they believe that vertical heights can be measured with angles when only angular size can be measured vertically. As if a cloud is 10 miles away and my angle to that cloud is 20 degrees, does that make the cloud 10 miles high? No is the answer, as a star can be 25 degrees above the horizon, making its ground position 4,485 statuate miles away, while a mountain that is 4,000 feet high can be 25 degrees in angular size at 9,020.9 feet of distance, so the horizontal distance does not equate to vertical height or altitude. As a lot of people on not just our opposing side but our own side have gotten this wrong and claimed things like the sun is 4,000 miles high. The truth is that nobody knows what heights the sun, moon and stars are at, and you won't know with angles alone. All you can do with an angle is measure the angular size of the free space between the celestial body and the surface of the Earth. And regardless of the miles distance between an observer and the GP of a celestial body, the vertical height or altitude can only be given in degrees, as 3,000 horizontal miles does not mean 3,000 vertical miles. As with the example of the 4,000 foot high mountain, that is 25 degrees in angular size at a horizontal distance of 9,020 feet. When measuring an angle to Polaris or any star, you can only measure the angular size of the free space between the Earth's surface and the apparent position of the star. So if the free space between Polaris and the Earth's surface is 70 degrees when close and only 30 degrees when far away, then all that has changed is you. At 70 degrees, Polaris would have a GP of 1,380 miles, whereas at 30 degrees, Polaris would have a GP of 4,140 miles. So, so does that make Polaris 1,380 miles high and 4,140 miles high at the same time? No. These are known straight line statue at mile distances. The only thing that has changed is the observer's ground and sea position with respect to Polaris. But Polaris didn't change and the Earth didn't curve, as both the Earth and sky remain parallel horizontal lines to each other. Our opposition think that you can measure huge vertical distances with angles when you can only measure angular free space between two objects. They constantly attack us with claims like Polaris won't drop 69 statute miles per degree over a flat plane, when a horizontal plane of the Earth and of the sky is what's needed to create this effect. What they also get wrong is they use an equator size of 24,900 miles when they should at least use an equator size that's just under 39,000 miles. Not that it matters, as you still won't find out the vertical height of Polaris or any other star by angles alone. But if you use a globe Earth equator size, then your angles will always be wrong if you're trying to equate it to a horizontal plane. But either way, they always ignore perspective and just claim that the Earth is curved, when a curved Earth is not only idiotic as a claim, as there is zero evidence to support this, but you can't get an angle off of a curved surface. Celestial navigation circles of equal altitude use the Earth's surface and not imaginary chord lines through a globe Earth when determining a line of position, also known as the zenith distance to the GP of a star, etc. So if anyone is claiming that celestial navigation is using a curved globe Earth to gain a radius line from an observer to the GP of a star, then they are claiming that a radius line can be curved. Moreover, a chord through a cross-section of a sphere won't work either. The reason it won't work is because the chord line will be representing a diameter to a 2D circle, but when placed onto a 3D sphere, the points at which that circle touched the sphere will not be equal locations, as the diameter of the circle will be less in distance than the arc of the sphere that resides within the confines of the circle. The circles of equal altitude are two-dimensional flat horizontal circles that can span over thousands of miles. This is an impossibility on a globe Earth. All zeniths, whether they be the observers or the zeniths of the three circles of equal altitude, must be, have to be, always are, always were, and always will be parallel to each other. Otherwise, sextant navigation would not work. Okay, I'm going to show a few diagrams. Here we have, it's going to make this one a little bit smaller. Okay, here we have a star up here, and you have, this is like a diagram that came from an official source, and they tried to put circles of equal altitude onto a globe. Okay, and the same official source will show you flat circles, 2D circles, three of them together. But because they believe or did believe in a globe, they didn't know any better and they didn't think it out. They just put them onto a globe. So this is why it won't work. Here you have an observer, right? This is their zenith. This is their angle? How are they getting an angle? Their angle is going off out into free space. This is right. How do they get this 90 degrees? They can't, because they're supposed to be getting a zenith or a radius line between this point and this point, and it has to go along the surface of the Earth. But obviously, this is a curved Earth, so you can't get a radius line. Can't get a radius line. Can't get a diameter. Can't get a diameter. Can't have a circle. If you look here, this is supposed to be another 90 degree from this star, but as you can see, both 90 degrees, both zeniths are diverging, and these are the bases of what would be a triangle are meeting off out in free space like two swords. So the whole thing is a complete farce. It can't work and it doesn't work, and that's not what they do anyway. But this is what they want to make themselves believe they do, even though they have to treat the Earth as flat when they're using circles of equal altitude. any of these circles, supposed circles of equal altitude here, will have a chord line through the center here that would be less in distance than the arc of the Earth that goes over the top of it here, the globe Earth that goes over the top of it here. So those distances, not only can you not get that because you need a radius, a straight radius and straight diameter, but the distance between the two sides of that circle will be less than the arc of the sphere that resides within it. So your coordinates and your placements will always be wrong. They'll never work. And your angles that you originally took off of a supposedly flat, the presumption of a flat plane, it would then change if you as soon as you put it onto a globe Earth, you bring them into the center of the globe, which changes the angles, which makes the whole thing completely pointless. Why even take an angle of a preassumption of a flat plane in the first place if you're just going to change it to the center of a globe and diverge the zeniths and make the whole thing impossible? I put it to anyone to use diverging zeniths and 3 diverging zeniths and a diverging zenith for an observer. See if you can get 3 circles of equal altitude that work. You won't, because you need a radius line for a circle. You can't have a curved radius. That's the end of that. Because the only way to have a radius to use the surface of the Earth and have a radius is for the Earth to be a horizontal plane. Can't work. Can't have a curved radius. Just something that is an impossibility. So how sections cannot work. I showed this before in my last video. These 2 boats. This is what I'm talking about. This boat here, right? This is the same angle, right here, as this, or appears to be the same angle here, right? But the problem is that when you try and fit this let's call it diameter here of what will be, this is the radius here of a circle of equal altitude. The diameter will be out as far as here. You try and fit that circle down onto this sphere here. That boat will go down to here, but all your placements will be wrong. They'll all be out. That's why the boats end up in 2 different positions. As this boat should be here, but it won't. It'll end up down here, and the other end of the side of the circle should be here, but it'll end up down here. So you'll be out by thousands of miles, hundreds, thousands. So this is an observer. These 2 are both representing Polaris. So angle A is 40 degrees and angle B is 80 degrees. So the only difference is that the observer is further from Polaris with angle A. So that means it has a 40 degrees. And with angle B, it has an 80 degrees. But the only difference is where the observer is. So the closer the observer is, the tighter the angle. The further the observer is, the wider the angle. That's all that's happening there. And it's just perspective. The Earth is treated as a horizontal plane. The sky is a horizontal plane. But it's just perspective. It gives the impression that Polaris is, or any star, the sun, moon, anything, appears to drop. It's an effect known as optical drop, and I will share in the description and maybe the comments as well a video showing this effect, and I have other videos detailing it. I think I was the first to detail it. I think within this arena. I started back in 2016 detailing it then to a surveyor. So it's a real effect. It's really there. I explained a whole lot in several different videos. But this is all that's happening here. It's just a perspective issue. As soon as you move away from Polaris, the angle becomes your angle to it changes. So the further you move away, the wider the angle, or let's say well, maybe yeah, it's more tight here with the 80 than it is with the 40. But the whole point is that as you move away, the Polaris will appear to drop in the sky, but that's because you have a parallel of 2 flat planes. That's the reason that happens. So there's no need for a curved out, something that makes the use of sextant and celestial navigation impossible. Close angles 60 degrees, close angle 60 degrees, far angle 220 degrees, 20 degrees. So a 500-foot high building. So close, when you're close to that building, it'll have an angle of 60 degrees. When you're far from it, it'll have an angle of 20 degrees. But it's still the same height above the surface of the earth. You can move away, but due to angular size change, basically all it is that a change in the angular free space, if you want to call it that, here. That's all it is, a change. Although you will have a building there, it's an angular size change of a building. If the building wasn't there, and just imagine it as like a star or something, or even just a drone at 500 foot high, when you move away, that drone will appear to drop. That's all it is. That's all, or a helicopter. That's all that's happening. So if you look at Polaris, it's the same thing. So Polaris, as you move away from it, will appear to drop in the sky, bringing your angle down. And when you're getting closer to it, it'll bring your angle up. And all the other stars are the same, except for they move. So when they're at your 80, when they're 80 degrees above you, at an angle of 80 degrees, as they move away, they'll go to a 40 degree angle, 20 degree angle. That's what happens. It's just that your angle to that star is changing as it's moving away from you, or as you move away from Polaris. The same thing happens with a building. There's no difference whatsoever. A building that's 60 degrees close to it will be 20 degrees when you're far away. There's no great mystery there. It's just what happens. It's just a part of perspective. This is showing how, if you can imagine this yellow circle being a circle of equal altitude, the green line is the diameter of that circle. That circle is placed onto a sphere. I'm using the white line here as, let's say, a sphere. So that becomes like a dome within the circle. But the white line here, right, is represented in a when that's straightened out, it's represented by this purple line. And as you can see, this purple line is greater in length than the green diameter. So even though you can place a two-dimensional circle onto a three-dimensional sphere, the diameter will never match the arc for distance. So your locations here and here that you plotted as a straight line distance with the circle of equal altitude will always be those locations will always be out, because they are not going to be here and here on the 3D sphere, because they'll be up here and over here. So there's be hundreds, thousands of miles. You'll be hundreds, thousands of miles out. So you can't do that. It's an impossibility. And you can't run a chord through a sphere, Earth, and then use that as a distance, because they have the same problem. It just doesn't work. It's an impossibility. You can't have a curved radius, and you have to use the surface of the Earth. So even you can't use the surface of a globe Earth because it's curved. You can't use that. You can't use that because you can't have a curved radius, and you can't run a chord through the center of it because you have the problem then of the placements on coordinates. So you can't do it at all if you're using the surface of a globe Earth, of a curved Earth. And even if you run a chord through that, the distances will be all out. It won't work. You'll never make it work because you're using straight line distances. When you're using a radius, because it has to become your radius and your diameter then, doesn't it? And that's going to be a straight line distance. So that's not going to fit on your arc. It's going to be all wrong all the time, every day, forever. Here I'm showing how you can't get a 90 degrees on a curved surface. So you have two straight lines and a curved line. You'll never make a triangle out of that. 90 degrees requires a triangle. So you can't do that. It's an impossibility. You can't use a curved bottom to a triangle. It won't be a triangle. Your angles will never be correct. Here is one I showed as well in my last video, just showing how you will have a 5,200 mile diameter of a circle of equal altitude if you've got a radius of 2,600 miles, which is common and often that they will have radii and diameters of that size and more. So the boat here, the person in the boat knows that in a straight line distance from their position through the sun's GP to the opposite side at the same distance, that there's a straight line distance of 5,200 miles. They know that there's a circle of equal altitude that has a diameter of 5,200 miles. They need to know that. That's something they need to rely on to triangulate their position at sea, because they're going to be using 2 and 3 circles of equal altitude to intersect each other and find their location. And to do that, they need a straight radius on the surface of the Earth, not a chord through some kind of a ad hoc globe Earth. A radius, straight radius and diameter along the surface of a horizontal plane. That's the only way it works. So here we have the sun's GP, right? This is the sun's zenith and the observer's zenith. The sun's GP, 4,000 miles, observer's GP. So this is the sun's GP here. That's the observer's GP. So as you can see, this is a right angle, right? Both of them are right angles. And there's 4,000 miles, I'm just saying 4,000 miles. There's a 2,000 mile radius, or a 2,000 mile radius and 4,000 mile diameter. So, a 4,000 mile radius and 8,000 mile diameter. Sorry. So there's 4,000 miles between the observer's GP and zenith and the sun's GP and zenith. But they both have to be 90-degree angles, and they both have to be able to meet along a straight horizontal line. It's basically, I could put another line up here and make a box out of this. It's a box basically, because you need 90-degree angles, and you need that to create an angle from the observer to the sun. So you can't have a situation like up here where you have that. This is completely incorrect. That doesn't work. It's not reality. You can't have a radius. A radius line is impossible because you've got a curved surface. It's just craziness. This is what it has to be for that to work. So 4,000 mile radius, 8,000 mile diameter. That's an 8,000 mile diameter of a circle of equal altitude. Here you have sun, distance from GP. Let's say this is 4,000 miles again. So this is a straight radius. How can you put that onto a spherical surface? You can't. You can't. A spherical surface has no. You can't have any straight line on a spherical surface. You can put a line on it and follow it around in a circle. You can make a circle, like they do with the longitude lines on the globe Earth. You can make a circle, but you can't have a straight radius. You can make a circle going around the outside of it, but you can't have a straight radius and a straight diameter. You have to put a chord through it, and it doesn't work, because for a start, you need to use the surface for circles of equal altitude. Number one. Number two, your chord and diameter. Sorry, your chord, which makes your radius and diameter. If you put it through, try and cheat, because all it is cheating. Trying to put it through mathematically through a sphere Earth. What's going to happen is the arc that resides within that circle will be more in distance, so your coordinates and placements, everything will be out. But they don't do any of that. They just use straight, horizontal, plain sailing measurements. That's what they do. There's no such thing as a straight line on a curved surface. It's an impossibility. You need to have you need flat, two-dimensional. You can't have a flat circle, and three flat circles on a curved surface. You can't have that. You can mathematically mess around with things, but you'll never get it all to match up. And you'll have to put chords through your sphere and make it up as you go along. And in the end, you'll have to come back to putting three two-dimensional circles onto a flat plane. because that's the only way it works. That's what they always do. It's what they always have done. They have to treat the earth, plain sailing, they have to treat the earth as flat. They treat the earth and sky as flat. That's the only way to do it. Radius, a straight line that originates at the center of a circle and ends at the perimeter. In geometry, a diameter of a circle is any straight line segment that passes through the center of the circle and whose endpoints lie on the circle. The circle is a two-dimensional 2D shape. It only has two measurements, such as length and height, and is usually called a flat shape. The ball, however, is a three-dimensional 3D shape because it has three measurements, length, height, and width, and is sometimes called a solid shape. A two-dimensional shape is a shape that has length and width, but no depth. A circle is one example of a two-dimensional shape. Circle of equal altitude. No matter what way you go around it, no matter what you try to do, you can never use this. This is a straight line distance measurement. You can never use this on a sphere Earth. It's impossible. All your zeniths will be diverging. All your radius and diameters will be chords going through your sphere. None of that will match this. All the placements and coordinates will be out. It'll all be wrong. This is what you have to try to do. A curved radius line. It's impossible. There's no such thing as a curved radius line. But the whole point of this video mainly was to talk about the circle of equal altitude, but it's mainly about Polaris, as Polaris is the baseline for all celestial navigation. So if they found out that when they moved further away from Polaris or closer to Polaris by an exact amount, that Polaris would drop or rise by an exact amount. And they found out the rest of the stars were the same, it's just that they weren't stationary like Polaris. So the rest of the stars acted the same, and they moved away from them or came towards them. If they come in towards them, they would rise in their view, and going away from them, they would drop in their view. And they figured out that they could then navigate the world using the sky and degrees to celestial bodies. But they had to treat the earth and sky as two parallel horizontal planes, as that's the only way it works. And no matter how they try and twist and turn it, no matter what they try and do and try and add their globe in, it'll never work. They always, and anyone can research celestial navigation, they always have to come back to flat plane, because that is reality. They can't ignore it. They have to do that. Okay, thank you.